Take a closer look at your body, and you'll find some surprising parts. Not because you need them today, but because your ancestors did long ago. These little leftovers may not have a big job now, but they are powerful reminders of how far we've come through millions of years of evolution. And we're just getting started. Stick around, because what's next might just change the way you see your own body. Let's begin with something fascinating you can try right now. Place your arm flat on a table, press your thumb against your pinky, and gently lift your hand. Do you notice a thin band rising in the middle of your wrist? That's the palmaris longus muscle, a small remnant from our tree-climbing ancestors. Surprisingly, around 10 to 15% of people don't have it, but it doesn't make them any weaker. There's absolutely no difference in grip strength, whether you have it or not. In fact, surgeons often use this muscle in reconstructive and cosmetic surgeries because we no longer really need it. This vestigial muscle is more developed in primates like lemurs and monkeys, which still rely on their forelimbs for movement. However, in species like chimps and gorillas that don't climb as much, the muscle has shrunk. It's a fascinating reminder of how evolution has sculpted our bodies, leaving behind parts that no longer serve their original purpose, but still connect us to our deep evolutionary history.
We've got more than one leftover muscle. Take the small muscles around your ears. Unlike many animals that can swivel their ears to hear better, we can't move ours much at all. But these muscles were once helpful for our ancient ancestors, who relied on sound to survive, especially at night. Scientists have found that these ear muscles still respond to sound. In one study, researchers hooked up electrodes to people's ear muscles and noticed a spike in activity when they heard a sudden noise. The muscles didn't move enough to actually pivot the ear, but they reacted, especially when the sound came from the side. So this is their left ear subconsciously trying and failing to pivot toward the sound. It's a fascinating glimpse of how these muscles used to function in our ancestors, even if they don't do much for us today.
Another example of our body's forgotten functions shows up when we get goosebumps. Ever wonder why that happens when you're cold or scared? It's thanks to tiny muscles attached to each hair on your body. When those muscles contract, they pull the hairs upright, creating those little bumps on your skin. For our furry relatives, this reaction served a purpose. Raised hair created extra insulation, helping them stay warm. You can see the same thing in birds, like a puffed-up pigeon trying to stay warm on a cold day. In animals, it's also a defense mechanism. Adrenaline, the hormone involved in our fight-or-flight response, triggers this reaction, making animals appear larger when they're threatened. The same hormone might explain why surprising moments in music or emotional scenes in movies can give you goosebumps. Even though we don't have much fur left, the response sticks around, a little echo of our past. So next time you feel those chills, remember it's your body calling back to a time when this reflex helped our ancestors survive. And then there's our tail, well, what's left of it. At the base of your spine, there's a small set of fused vertebrae, which we call the tailbone. Some people have 3 of these vertebrae, others have 5. Today, it serves as an anchor for pelvic muscles, but originally, it was part of our ancestors' tails. Believe it or not, every one of us actually had a tail at one point in development. Around 4 weeks into gestation, human embryos have a tail with 10 to 12 vertebrae, just like the embryos of many other animals. In species like cats, dogs, or monkeys, this tail continues growing into a fully functional appendage. But in humans and other apes, the cells that form the tail get a signal to die off after a few weeks. Occasionally, though, a rare mutation occurs, letting this ancient blueprint take over, and a baby is born with a small, true vestigial tail, a fascinating reminder of our deep evolutionary past. Subscribe for more fascinating facts. Thanks for watching.